All right, so here's just a little help on the homework section 10.3. Okay, so I'm just going to do a few problems for you, make sure you guys are on the right track. So let's start right here with number 1. Each regular polygon has radii and apothem as shown. Find the measure of each angle, right? So there's a formula with the number of sides, -1 times 180, right? Let me show you a different way to do that. If you are a little confused from the notes, most kids are pretty good that it's 360 degrees in a circle. So for number 1, you know that there's 360 degrees in that center divided by 3. So each angle in the center is equal to 120 degrees. So angle 1, the measure of angle 1, would be equal to 120. Okay, and then we know from that if we cut that 120 in half, right, because we just click on that, if we know now each of these angles here is 120 degrees, well, this angle 2 is just half that because we're dropping an apothem down, right? That's the apothem, the one that comes straight down. And that splits the angle, it bisects it, right? So if it's 120, then the measure of angle 2 is just equal to 120 divided by 2, which is just 60, right? And then the measure of angle 3 would have to be 30, right? Because we have a 90 and we have 60, and we know that angle 2 and 3 have to be complementary. They have to add up to 90. So we know angle 3 would be 30 degrees. So that's how you do those. You figure out the center angle, cut them in half, kind of process of elimination and move around. So there's a different method than the one shown in the notes on how to do that one. Okay. Then we're going to come down here and we're saying find the measures of the angles formed by 2 consecutive radii and B, a radius and a regular side. So let's just talk about what that means. So maybe we could take a look at an octagon. Let me do my best to draw an octagon here. So we would have 1, 2, like that. It's kind of our stop sign there. So there's one side of the octagon, there's another side. There's the side of the octagon. That's not a great one, but that's the best you're going to get. Coronavirus. All right. So there's an octagon. It's got 8 sides, right? And they want to know what are the measures of angles formed by 2 consecutive radii. So that would be if I have a center here, there's one radii, there's the other consecutive. So they want to know what that angle is there. So we'll call that angle A. Then they want to know a radius and a side of the polygon. So here's a radius right here, and here's a side of the polygon. So there's angle B. And they want to know what those angles are, right? So we know that in an octagon, there's 360 degrees around that center, right? Around this center. And there's 8 angles. So if we divide that by 8, then angle A is just equal to 360 degrees divided by 8, which is 45 degrees. So I know angle A is 45 degrees, right? And then if I dropped an apothem down, do that in red. If I dropped an apothem down from here, down to the bottom, it would form a 90 here, right? So half of that 45 would be the little angle up in the corner. So let me see if I can squeeze that in for you guys. So I know that half, where's my cursor? Right here, half of the 45 is 22.5. So that angle right there, let me blow that up for you. Right now we know this is 45. So when I drop the apothem down, this little piece here is 22.5, right? Because I have to cut that in half, which means that if I subtract that from 90, that would give me the angle on the side. So the B angle would just be 90 minus 22.5, which is 67.5. Okay, so again, I found A to be 45. To find B, right, I know I'm going to drop this down, right, find that, find the angle up top to be 22.5 and subtract it from there. The other way of looking at that is that if you know this angle up here is 45, you know, since it's a regular polygon, that these two angles, those two sides are equal, which means these two angles have to be equal. So if they all have to add up to 180, that means that 135 would have to make up those two angles there. And if you cut 135 in half, you get 67.5 degrees. So hopefully that helps with that problem. All right. And let's see, let's scroll down. I'm not sure why there we go. So let's look at number 4 here. Find the area of a regular polygon with a given apothem and side length. So let me work over here on the side. So for number 4, we know the area of a regular polygon is equal to, or we should know if we looked at the notes, is equal to half times the apothem times the perimeter, right? This is perimeter. This is apothem. So for number 4, right, the area is just equal to 1/2 the apothem times the perimeter. Well, it's a pentagon, right? So the perimeter is going to be equal to 5, because there's 5 sides, times the length of one of those sides, which is 35.3. So this right here is my perimeter. You do that math out, and that's how you find the area. Okay, moving on, let's take a look at these. I'm not sure why that star is there. All right, find the area of each regular polygon and round your answer to the nearest tenth. Okay, so we start to get into some, let's do that first one. Oh my God, that's awful. Okay, so there's what's supposed to be a regular hexagon, right? There's 6 sides, and we know this side is 18, which means we know all sides are 18. So if I'm trying to find the area, it would be great if I knew the apothem, right? Because I could do 1/2 the apothem times the perimeter, right? And we know the perimeter right now is going to be 6 times 18. So all we need is the apothem, and we can make our formula correct. So how do we find the apothem? So let's take a look at this triangle right here, or any of the triangles, right? But I'm going to draw it out for you here. How do we find the apothem, which is this right here, if we know the bottom is equal to 18? Well, if we know the bottom's equal to 18, we know that this little piece right here is equal to 9. Okay, so really what I'm trying to do now is I'm trying to find, or I'm trying to focus on this triangle right here. Okay, and you could use trig if you want, but if you remember your 30, 60, 90 stuff, this is where you'd want to use them, because we know in a hexagon, this is 360 degrees. If I divide it by 6, this angle right here is 60. If I cut that in half, that means this angle right here at the top is 30, which means this is 60, right? And I have a 30, 60, 90 triangle. If this is 9, then the apothem has to be 9 square root of 3. So if you remember that from your special right triangles. Now you could use trig if you want, but this is much quicker if you remember your special rights. Okay, so we know the base here is 9. We know the apothem is 9 radical 3. So I can plug that in here, and I can say my area is equal to 1/2 my apothem, which is 9 radical 3, times the 6 sides of 18. So here's my perimeter. Here's my apothem. And do that math out, round to the nearest tenth. Okay, and that should help you do those problems. All right, moving down. Let's see if I can give us some space under this 14. Find the area of each regular polygon with the given radius or apothem. If your answer is not an integer, leave it in the simplest form. So, we could take either of these. We could take this one over here, and we could say, all right, I know that this apothem is 8 radical 3. I also know it's a hexagon, so I know it's 360 degrees, that each angle is going to be 60, which means this angle here is going to be 30, which means I have a 30, 60, 90 triangle. If the apothem, the long leg, is 8 radical 3, then to find this, I divide by radical 3, which means this little piece here is 8, which means the length of all the sides are 16. So the area is equal to 1/2 of the apothem times the perimeter, which is 16 times 6 sides. And there's your answer. Just do that out, round to the nearest tenth. Okay, last type of problem. Find the area of each regular polygon. Same type of thing, right? If it's not an integer, leave it in simple radical form. So they don't want you to write it as a decimal on these, right? So let's take a look at the first one. We have a hexagon, right? And we're trying to find the area. It's a regular polygon. So again, we know it's 1/2 of the apothem times the perimeter, right? So what is the perimeter of this? Well, we don't know. All we know is the radius right here, right? So we need to find the apothem and the sides. So we know that these little triangles here form 30, 60, 90. So if, let me erase that, I don't want to confuse you. So if I drop an apothem down, let's zoom in here a little bit. If I drop an apothem down from right here, right, I want to know what this is right here. So I know this is a 30, 60, 90 triangle, okay? And if this is 6 square root of 3 for the hypotenuse, and I know it's a 30, 60, 90, then I know in order to find the short leg, I'm just going to divide this by 2. Right? Because short leg times 2 equals the hypotenuse, so the hypotenuse divided by 2 equals the short leg. So this little piece here is 3 square root of 3, which means the total side length is just 2 times that, right? So it's going to be 2 times 6 square root of 3, so this is just going to be 6 square root of 3 is going to be the side. The height here is going to be 3, the short leg times the square root of 3, right? So the long leg is just equal to the short leg times the square root of 3. The square root of 3 times the square root of 3 is 3, times 3 is 9. So I know my height, or my apothem, is 9. So my equation, 1/2 of the apothem times the perimeter, which there's 6 sides, at a length of 6 radical 3. Since they said simple radical form is fine, we're going to take 6 times 9 times 1/2, right? And we're just going to leave the radical 3. So that's going to be 1/2 of that is 3. 3 times 6 is 18. And 18 times 9 is 90, and 63 is 153. So my answer is 153 times the square root of 3. Okay, so maybe brush up on your special right triangles if that seemed confusing to you. That might be, and I actually screwed that math up, I think, now that I look at it. Hold on. It's not 153. The area is equal to, hold on, 1/2 of 6 I did is 3. 3 times 8 is 3 times 6 is 18, and 9 times 18 is 162. So that was my bad. 162 square root of 3. Okay, so there is your area. Brush up on your special right triangles. That'll kind of help you go through these. All right, and now they're always not going to be like, if you look at this one here, the next one, number 17, that's not a 30, 60, 90 triangle in the same instance that this was, right? But if you do your math out, you're going to realize that this is the 30 in this one, and this is the 60. Okay, so it is still a 30, 60, 90. It's just laying flat versus straight up and down. Okay, you might get a 45, 45, 90 on some of them, and so on and so forth. So I'll be going over those in the Math Lives, but if you have any questions on those, let me know.